Okay, for problem 12, we've got to solve by factoring. So you're going to have to show your work on this and show how you get that. And then write your solution as a set. That means you're going to write your solution in the little brackets. Okay. All right, if I have 9x squared minus 42x plus 49 equals 0, I recognize this as a perfect square pattern. I know this is 3x to the second, 49 is 7 to the second, and this is the opposite of 2 times 3x times 7. So I know this factors immediately into 3x minus 7 squared is equal to 0, which is the same thing as 3x minus 7 times 3x minus 7 equals 0. Now, of course, when you're factoring and I'm solving, I just didn't even think about it. It has to be set equal to 0. Well, I'm going to solve each of these, but since they're identical, I only have to solve it once. So that gives me 3x minus 7 equals 0. When I add 7, 3x equals 7, divide by 3, so x is 7/3. So my solution is 7/3, and you'll learn in the next week what it means when there's only one solution. Okay. Now, if I don't recognize that as a perfect square, I'm going to take this and I'll multiply my 9 times 49. So I'm going to look for two numbers whose product, and what is 49 times 9? 441. And they add up to negative 42. So I'm going to find all the factor pairs of 441. Well, let's see. There's 1 times 441. Since it's 3 times 147. It's 7 times 63. And it is 9 times 49, and it is, the next one I think is 21. So it's 21 times 21. And they both have to be negative, so I can see that it's negative 21 and negative 21. Now the whole point of doing that is I know negative 21 plus negative 21 is 42, so negative 21x plus negative 21x is equal to negative 42x. So I can replace that middle term. So this becomes 9x squared minus 21x minus 21x plus 49 is equal to 0. So I'm going to split this into group it in two different groups. So this is 9x squared minus 21x plus negative 21x plus 49 is equal to 0. The greatest common factor here is 3x. So it's 3x times 3x minus 7. I'm going to pull out a negative here. Again, the greatest common factor is 7. And that leaves me with 3x minus 7 equals 0. So I have 3x minus 7, my common factor, and when I pull that out, I'm left with 3x minus 7 is equal to 0. And I'm right back where I started. Okay, on B, it is not equal to 0. So it must be equal to 0. That is my first step, and my pen is leaking all over the place. All right, so this becomes 2x squared plus 11x minus 40 is equal to 0. I have to subtract 40 from both sides. There's no greatest common factor, so I'm looking for two numbers whose product is negative 80 and whose sum is negative 11. So the factor pairs of 80, and one has to be negative. And since the sum is negative, the larger has to be negative. So I have 1 times 80 I have 2 times 40. I have 4 times 20. I have 5 times 16. I think it's 6 times 15. Nope. So it's going to be 8 times 10. And I think that's it. Okay. So I'm going to make this one the negative and find the pair that adds up to 11. I'm sorry, that's positive 11, excuse me. So these have to be positive, and these are negative. And let's see, that one doesn't work, that one doesn't work. That adds up to 16. Here we go. This is the one that adds up to 11. So this gives me 2x squared minus 5x plus 16x minus 40 is equal to 0. I now group them as 2x squared minus 5x plus 16x minus 40 is equal to 0. Greatest common factor here is x times 2x minus 5. And the greatest common factor here is 8. And I'm left with 2x minus 5. That equals 0. So my common factor is the binomial 2x minus 5. And I'm left with x over here, and I'm left with 8 over here, and it equals 0. So, since the product equals 0, one of them has to equal 0. So 2x minus 5 is equal to 0, or x plus 8 is equal to 0. So here I'm going to add 5 to both sides. 2x equals 5. Divide by 2, and x is 5 halves. Subtract 8 from both sides, so x is negative 8. And writing it as a set, that's negative 8 and 5 halves. Okay, not equal to 0. So in one fell swoop, I'm going to have to subtract 8x from both sides and subtract 4 to make it equal to 0. So I have 2x to the third plus x to the second minus 8x minus 4 is equal to 0. This is 4 terms. I look for a greatest common factor. There is nothing in common to all 4 of them, so I'm ready to group. So 2x to the third plus x to the second plus negative 8x minus 4 is equal to 0. Greatest common factor here is x to the second, and I'm left with 2x plus 1. I'm going to pull out a negative here, and it's a negative 4 times 2x plus 1 equals 0. Greatest common factor now is the binomial 2x plus 1. I'm left with x squared minus 4. But now I notice this is a difference of squares. So this becomes 2x plus 1 times x plus 2 times x minus 2 equals 0. Because this is x squared minus 2 squared, a difference of squares. Okay, so 2x plus 1 equals 0, which means 2x is negative 1. So x is negative 1/2. X plus 2 is 0, which tells me x is negative 2. X minus 2 is 0, so x equals 2. So my solutions are going to be, and it doesn't matter the order, as long as you list them all. Okay, it has to be equal to 0. So I'm going to subtract 21 from both sides on this one. So I have x plus 3 times x minus 1 minus 21 is equal to 0. This is not in factored form. I'm going to have to multiply it all out and then factor it again. So if I multiply this out, this gives me x squared minus x plus 3x minus 3 minus 21 is equal to 0. So this gives me x squared plus 2x minus 24 is equal to 0. So I'm looking for two numbers whose product is negative 24 and whose sum is a positive 2. The factors of 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6, and here we go, because these are going to be negative, the smaller one. If I add those together, that gives me my 2. So x squared minus 4x plus 6x minus 24 is equal to 0. Now I can group them into x squared minus 4x plus 6x minus 24 is equal to 0. This gives me x times x minus 4 plus 6 times x minus 4 equals 0. Common binomial factor of x minus 4, I'm left with x plus 6 equals 0. So x minus 4 is 0, which tells me that x is 4. X plus 6 is 0, which tells me that x is negative 6. And I ran out of room, so I'll write my solution up here of 4 and negative 6. Now, the difference between this one and this one is this was factored, but it equals 21. This is all factored, but it equals 0. So I don't have to do anything except set each factor equal to 0. So either x is equal to 0, 3x plus 13 is equal to 0, or x minus 4 is equal to 0. Well, that's done. Here I'm going to subtract 13 from both sides and then divide by 3. Here I'm going to add 4. So my solutions are 0, negative 13 over 3, and 4. Okay. This is equal to 0. I notice this is to the third power. We don't know how to factor those yet. We don't know how to actually solve those. So we will here in a couple of weeks. But so I definitely want to look and see what I can do with this. Especially see if there's a greatest common factor. And there is. Notice both of these terms have an x. So I can factor this as x times 36x squared minus 25 is equal to 0. Well, I notice this is a difference of squares. This is 6x to the second minus 5 to the second. So this factors into 6x plus 5 times 6x minus 5. And I also have an x in there, and that equals 0. So x equals 0. 6x plus 5 equals 0, which tells me that 6x equals negative 5. Or x equals negative 5, 6. 6x minus 5 equals 0. 6x equals 5, so x equals 5 over 6. So my solutions are 0, negative 5 over 6, 5 over 6. Okay, this is equal to 0. No greatest common factor. It's to the second power. So all I have to do now is find two numbers whose product is 21 and whose sum is 10. The factors of 21 are factor pairs and 3 times 7. That's all there are. And there's our winner. So this is x squared plus 7x plus 3x plus 21 is 0. X squared plus 7x plus 3x plus 21 equals 0. This gives me an x times x plus 7 plus 3 times x plus 7 is equal to 0. Common factor of x plus 7, I'm left with x plus 3, whoops, and that equals 0. So if x plus 7 equals 0, that means x equals negative 7. If x plus 3 equals 0, that says x is negative 3. So my solution set is negative 7, negative 3. Okay. All right, not equal to 0. I like to have the lead coefficient positive, so I'm going to subtract 7x from both sides and subtract 40. So this gives me 3x squared minus 7x minus 40 is equal to 0. I want to make sure I have enough room here. Okay, so 3 times negative 40. I'm looking for two numbers whose product is negative 40. I'm sorry, negative 120, excuse me, and whose sum is negative 7. Okay, so the factor pairs of 120, and since this is negative, the larger one is going to have to be negative. So I have 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 12, and there's my winner. That's not right, though. Oh, it's not 5 times 12, it's 5 times 24. Grr. So 6 times 20, 8 times 15. That's what I'm looking for, is the 8 times 15. There it goes. All right, so that's how I'm going to split it up. 3x squared plus 8x minus 15x minus 40 is equal to 0. So this gives me x times 3x plus 8 minus 5 times 3x plus 8 equals 0. So 3x plus 8 times x minus 5 is equal to 0. 3x minus 8 equals 0. 3x equals 8. I'm sorry, this is a plus, so that's a minus. So x is negative 8/3. X minus 5 is 0, which tells me x is 5. So my solutions are negative 8/3 and positive 5. And my pen is pooping out on me. Okay, so hopefully it'll stay for one more, and then I can try and find another black pen. If not, maybe I'll switch to blue. Okay, so x squared minus 3x minus 54. All right, so I'm looking for two numbers whose product is negative 54 and whose sum is negative 3. Okay, well, the factor pairs of 54 are 1 times 54, 2 times 27, 3 times 18, and 6 times 9. And that's all of them. Oops, I'm sorry, you can't see that. Okay, so this becomes x squared, and this has to be the negative one, plus 6x minus 9x minus 54 is equal to 0. So x times x plus 6 minus 9 times x plus 6 is equal to 0. X plus 6 times x minus 9 is equal to 0. X plus 6 is 0, so x is negative 6. X minus 9 is 0, so x equals 9. And your solution set is going to be negative 6, 9. Okay, one more video to go on the applications.